Hello, you guys. I am going to be talking about calculating compound interest today. Now, compound interest is the most common type of interest that is either charged or earned on most accounts. It's going to be something that is paid not only on your principal, as the wording says there, but also on any interest that you have previously earned. Every time interest is calculated, the interest is added to the principal for future interest calculations. So if you notice, this is 8.12D, where we would compare simple interest to compound interest, and then 8.12C, which talks about how if we invest small amounts of money over time, then it can grow into a larger amount. Now, your formula for compound interest is going to be A, that's the amount that would be in the account after a certain number of years. So again, A is equal to P, which is principal, times 1 plus your rate, which is always in decimal form, to the power of the time, okay? And remember, your time is always going to be in years. Now, I want to give one caveat, though. This will work, that formula, only when on a yearly basis, like I'm going to be doing in my example. So if, for instance, you had $1,000 that you wanted to sit in an account and grow over time, this is without any additional additions, this formula works. But if we're doing it on a regular interval, basically like I'm going to be showing you in the example where we're going to be compounding interest on a yearly basis, then the t, that exponent t, is only going to be 1. Okay, so let's go ahead and move over to our work now. The example that we're going to be working with deals with Fredo. Okay, Fredo is going to be saving money, and it looks to be that he deposits $75 each year into an account that is going to be earning 3% interest compounded actually annually. If he deposits any additional, if he deposits an additional $75 per year and does not make any withdrawals, how much interest will he earn at the end of the 4th year? Okay, so let's go ahead and switch over to my work. We see here that we're going to actually go ahead and start our table. And this is the best way to organize all of our information, in that we can see what we're dealing with on a annual basis up to year 4. All right, so when she walks first into the bank, of course she's not going to have any money in the account. That's going to be a 0 balance, okay? The amount that she initially deposits, or he, I should say, will initially deposit is going to be $75. So my new balance will be $75, stands to reason. Now, at this point, the formula, again, that I would be using is where the amount in the account is going to be equal to the principal times 1 plus the rate to the power of time that we're using. And in this case, it's going to be 1 year. So what I'm going to do is I'm going to show you what that would look like for the first year, and then I'm going to show you what a little bit of a shortcut would be to calculate the rest of the interest amounts. So we know that our principal in this case is going to be $75. I'm going to multiply that by 1 plus our rate, which is 3%. We always put 3% as a decimal. So in this case, it's going to be 0.03. The amount of time is going to be 1, because that's 1 year. Okay, any number to the first power is going to be that same number. Simplifying the expression, it becomes 75 times 1.03. I left off the 1 to the first power because, remember, like I said, anytime you simplify this, what's inside the perimeter, or the parentheses, sorry, to the first power is going to be 1.03 when I simplify by itself. When I multiply 75 times 1.03, that interest amount, or the amount that I would get, and I'm going to use my calculator here. I will go ahead and clear all of my numbers that I was dealing with. That's 75 times 1.03. That's going to give me $77.25, as you see. Now, I'm not going to write that in the amount of my interest, because this formula tells me the amount that would actually be in my account. This A is the amount that's actually in the account. So that amount would be $77.25. Well, wait a second, Mr. Moore, how do I figure out what the interest amount would be? So it stands to reason that this balance plus some number is going to equal my end balance. So all that I do is I will subtract my amount in my account. This answer is going to be that amount minus 75. And I think that I'd already put it minus symbol. Minus 75 is going to be $2.25 in interest. Now that doesn't seem like a lot, but if you are a lender or a bank, when you're lending out millions of dollars, or if you're saving possibly millions of dollars, it's going to add up to be a fairly significant amount. Now the difference between simple interest and compounded interest is the fact that this amount is going to be added to my new balance. So I'm going to start off with 77.25. The amount that I'm going to deposit again at the beginning of that next year is going to be 75, which turns into $152.25. I'm going to use my formula again, and I'm just going to use this standard amount because I know that it's still going to be 3%. I know that it's still going to be to the first power, so nothing really changes except this amount is what I'm now going to be multiplying by. So the new balance times 1.03 is going to give me the new amount in my account. So let's see what that is. 152.25 times 1.03. It's going to give me my new amount in my account. Well, wait a second, Mr. Moore. That has 3 numbers after the decimal. It does have 3 numbers after the decimal, but keep in mind that we don't express money in 3 places after the decimal. So what we have to do is we have to round. So that's 156.82. This number right here tells me what I do with that number. Do I keep it as is or do I round up? And in this case, I do round up. Now, just like I did before, I'm going to subtract this amount, which I can keep in the calculator as that, minus my amount that I had before, 152.25. That's going to give me an interest amount of 4.5675, which I'm going to round to $4.57. Okay, and I'm going to continue to do that exact same thing. I'm going to carry my balance forward again, 156.82, adding in an additional $75 at the beginning of that next period. That will then become $231.82. I'm doing a lot of these calculations off camera for just the sake of time. Okay, now 231.82. I want to go ahead and multiply that number one more time. 231.82 times 1.03. Again, that's my 3%. It's going to give me 238.775. Okay. 238.775. So in this case, my amount is actually going to be 238.78. Okay. So 238.78. I'm going to carry forward. But first of all, I need to get my amount. So 238.78 minus 231.82 is going to give me $6.95. Okay, $6.95. Now, I am going to take my new amount, 238.78, carry it forward. Okay, when I carry this forward, I'm going to add in my additional amount of $75. 238.78 plus 75 will give me 313.78. Okay, 213.78. Now I'm going to use that exact same number multiplied by 1.03. Again, my interest rate, which will give me 323.19. Okay, so that's going to give me 323.19, which I'm then going to subtract. That's minus 313.78. Okay. Doing this again off camera, 323 minus 313.78 is going to give me $9.41. Excuse me. All right, so the amount that I have earned for all four of these years, I could simply total up, okay? The amount that I earned in these 2 years, I would total these two numbers up. If I wanted to figure out all 4 years, of course, I'm going to total them all up. Now, how does that compare with what it would be with simple interest? Now, what I've done for the sake of time is I have calculated, and you can go back to my video on simple interest, I've calculated the amount that would be earned in terms of simple interest on this particular account. It's $22.50 over those 4 years. Now, how much would this be for compounded interest? We see that if I were to total that amount up, it's going to be $23.18. $23.18 is the amount for compounded, $22.50. So as we see here, there is a gap here of about 68 cents. So you're asking yourself, Mr. Moore, that's less than $1, okay? But this is a relatively small amount. Remember, when you magnify this, and again, if there are millions of dollars or hundreds of thousands of dollars that are being saved, that can be a fairly significant amount. That would be different. So typically, again, banks are going to use compounded interest in terms of lending and in terms of when they have people to actually save with them. That is it, you guys. So if you have any additional questions, please come to class prepared with a question for me. If you still don't understand, come to tutorials on either Tuesday or Thursday. Rewind this video, watch it again maybe to see if that will make some things click. And as always, you guys, I will see you tomorrow in class.